Hello. Today I will be discussing AR tracking and 3D reconstruction with OpenCV. Particularly, I wanted to show how I implemented pose estimation of a known image and used it to calculate relative poses of a moving camera looking at a fixed 3D scene. First, with any computer vision task, we must start by getting our camera's intrinsic matrix. If this is not given by the manufacturer, we can calculate it with some tools from OpenCV. One way to do this is using a printed pattern of alternating light-dark squares, such as a chessboard, and OpenCV's find chessboard function. We then compute the corners, visualize these points, discard unsatisfactory images, and calibrate the camera through a series of functions in the OpenCV library. By the end, we have the intrinsics and lens distortion of our camera. Next, we use the brisk method to determine key points in our 2D AR marker and use these key points to track a printed image in 3D space. We want to do more than just follow along with our 3D world though. We want to compute the actual pose of our image within that world and use this for 3D reconstruction later. For this, we use the find homography function from OpenCV, as well as singular value decomposition to find the extrinsic parameters, the rotation and translation of our image in 3D. Now is when it starts to get interesting. Since we know the intrinsic parameters of our camera and the extrinsic parameters of our image in space, we can use this information to do fun things like attach virtual objects to our physical one. The next stage of the project is 3D reconstruction, where we can use the relative rotation and translation from one 3D scene to another, coupled with only the best key point matches, to reconstruct the 3D scene. I'm still working out the bugs in my function to check whether those key point matches are robust across images. So at this time, I will say thank you for watching my video and take care.